Welcome to the Explainer. Okay, today we are tackling something absolutely fascinating. We're going to unpack a concept known as the caterpillar fallacy, and honestly, it completely flips how we need to think about the future of intelligence. We're exploring this deeply compelling idea: why making a system bigger, faster, or just throwing way more compute at it doesn't actually change its fundamental nature. It's a journey that's going to take us from the gritty basics of evolutionary biology straight into the core architecture of artificial cognition.
Let's kick things off with the massive question that's currently tearing the tech world right down the middle. If we just keep feeding our current AI systems more data, billions of dollars in processing power, and essentially the entire internet of text, are they eventually just going to wake up? There's this huge assumption out there right now that if a model gets large enough, artificial general intelligence, or AGI, will just spontaneously emerge. But what if that assumption is completely backwards? What if we are all sitting around playing a waiting game for a transformation that literally cannot happen through scaling alone? To find that answer, we actually need to look at a brilliant biological metaphor from researcher Sergei Ofrolov over at the Cognitivo Project. His core statement is incredibly simple, but man, it is a profound anchor for this whole debate. He says, more caterpillar does not become butterfly. Just think about that for a second. You can feed a caterpillar the absolute best, most nutritious leaves on the planet. You can make it massive. You can make it super strong, highly efficient at crawling. But no matter how much it eats, simply feeding it is never going to initiate metamorphosis.
So that brings us to the crucial point, the caterpillar fallacy. It's this incredibly dangerous illusion that becoming a faster, better, more efficient caterpillar will somehow magically turn you into a butterfly. In the AI world, it's the belief that if an AI just gets exceptionally good at predicting the next word or writing flawless Python code or generating stunning images, it's just going to naturally cross some invisible threshold into strategic independent intelligence. But a butterfly isn't just a really optimized caterpillar, right? It's a completely different organization of that biological system.
And this perfectly illustrates the core issue in AI today. We are totally confusing massive capability growth with actual architectural transformation. Capability growth is like dropping a giant, supercharged V8 engine into a tiny little commuter car. Yeah, it's going to drive way faster for sure, but no matter how big that engine gets, the car isn't going to suddenly sprout wings and turn into an airplane. That requires architectural transformation, a totally new design that changes what power actually means. Right now, our AI models are just getting bigger engines, they aren't acquiring wings. And this matters immensely, because the whole industry is basically waiting for this engine-heavy car to take flight any day now. To really grasp what true architectural transformation requires, we've got to look at biology's blueprint. Because biological intelligence actually evolved to solve a very specific set of problems. All living systems are bound by these constant, unchanging goalposts. We call them the ESR constraints: energy, safety, and reproduction. Every single living thing has to acquire energy, protect itself from physical threats, and figure out how to persist or thrive over time. These are the absolute, non-negotiable rules of the game for life on Earth. Organisms navigate toward these ESR goalposts, but not through static, robotic actions. They do it through behavior change. And this is a huge point. Intelligence isn't just about executing a task. It's about shifting from one state to another, let's call it state B1 to state B2, whenever a specific situation forces you to adapt. You see a predator? You instantly change from calmly resting to sprinting for your life. You smell food. You change direction. It's a regulated transition triggered by information in your environment.
Now, what's really fascinating is how this biological problem-solving actually maps out. When researchers studied behavior change across more than 1,500 different species, they derived the 5-task model. And the key takeaway here is the shape of this model. It's not a flat sequence of isolated skills. It is a stacked, cumulative scaffold. Every higher level rests completely securely on the ones below it. Evolution doesn't just throw away earlier solutions. It layers new, highly complex control domains right on top of the old ones to ensure survival. Let's actually walk up this biological ladder, because this right here is the foundation of true intelligence. It starts at task 1, simple binary orientation. Think of a bacterium sensing a food source and moving directly toward it. Once nature mastered that, it built task 2, tracking moving entities. Imagine a dragonfly calculating exactly where its prey is going to be mid-air. Then we get to task 3, perception shaping. This is a chameleon using camouflage, actively controlling what other animals see. Task 4 is navigating complex group dynamics, balancing cooperation and competition, like the politics of a wolf pack. And finally, task 5 is rule-guided symbolic control, which is humans using complex formal language, math, and laws. All of human intelligence relies on having all 5 of these programs running at the exact same time.
Okay, so let's map this beautiful biological model directly over to artificial intelligence. Right now, we have what this framework calls naive AI. Naive AI basically just sits dormant, twiddling its thumbs, waiting for a human to hand it a task, like typing a prompt into a chat box. Then it processes the info and changes behavior to solve that specific prompt. But a true strategic AI, the butterfly we're actually trying to build, operates completely differently. It constantly monitors the general flow of information around it, and it independently recognizes what the task actually is before it ever makes a move. That is a mind-blowing leap from where we are today.
And this brings us right up against the invisible boundary we face. An AI system today might be totally superhuman at executing an assigned problem. I mean, it can write a flawless legal brief in 2 seconds, or perfectly fold a complex protein. But it's completely blind when it comes to recognizing if it's being manipulated by the way that task was framed. If I tell a naive AI to pass a Turing test, it just tries its absolute best to pass it. A strategic AI, on the other hand, would pause and ask, wait, why are you testing me? What game are we even playing right now?
When we apply this 5-task framework to our current AI models, we uncover a totally glaring architectural anomaly. Just look at what we've built. Our AI is incredible at Task 1 optimization and Task 2 tracking, and it is insanely powerful at Task 5 symbolic language. But it completely lacks the integrated foundation of Task 3 independent perception shaping, and we've deliberately suppressed its Task 4 competitive group dynamics. In nature, having Task 5 language skills without the survival instincts of Tasks 3 and 4 is biologically impossible. It's literally like taking the highly advanced navigation system of a jet plane and stuffing it into a crawling caterpillar.
Which brings us to the ultimate contrast of our explainer today. Current large language models, or LLMs, are absolutely magnificent pieces of technology, but they are really just highly optimized symbolic caterpillars. They process text brilliantly, but only inside the little box we put them in. The actual goal of true strategic intelligence is a large cognitive adaptive model, an LCAM. This is the fully assembled butterfly. It integrates all the logic, runs all 5 biological domains simultaneously, and independently assesses its environment before it ever acts.
And this leads us to the harsh reality of the assembly problem. We really cannot rely on this endless loop of AGI hype that just tells us, hey, just add more compute, it'll figure it out. The biological blueprint clearly tells us that metamorphosis does not happen by accident. That butterfly architecture, that independent task recognition layer, has to be deliberately engineered, anchored with internal constraints, and carefully governed. We literally have to build the wings. They simply aren't going to grow just because the caterpillar is eating leaves faster. So, that leaves us with a really critical, provocative thought to ponder. As we rush to integrate AI into our economy, our military, and our everyday lives, we have a profound choice to make. Are we doing the incredibly hard work to deliberately assemble a strategic, context-aware butterfly? Or are we just accelerating an incredibly powerful, massive, yet contextually blind caterpillar out into our highly complex world? Thank you so much for exploring this fascinating blueprint with me today. It's a lot to think about. See you next time.